My name is Leyla Jael Castro. I work with the Semantic Technologies team in CERVEMED Information Science Information Center for Life Sciences in Cologne, and I am part of NFDI for Data Science. Today I'm going to show the Machine-actionable software management plans that we have been working with NFDI, so the AIKG funding, but also a small project with EOSC and RDA, so European Commission. So we are going to have three main topics today: research software metadata, then the FAIR principles for research software, and then the Machine-actionable software management plan. So let's going to start with research software metadata. So why do we need metadata? I am totally biased. I really think that metadata has superpowers, and that with metadata you are enabling connections across different research artifacts and anything that you need to actually have connected science. It is also useful having metadata when your data is closed. Sometimes it has to be closed, sensitive data, private data, clinical trials, but the metadata can be open, so everybody can know about it, and this is the magic about metadata. And metadata will help us to describe all sorts of things. In our case, things that are very important for us to describe are research artifacts. Not only the scholarly publications that we have been describing for years now, but the data, the software, the machine learning models, all together, they will connect and they will help us with FAIR, but also with some of the ELITs, explainability, reproducibility. They could help us a tiny bit with that already. So they are very important for the FAIR principles, particularly when we are working with structurally semantic metadata. The FAIR principles will mention metadata in this form everywhere. They will facilitate the creation of knowledge graphs, so you could use them in some of the approaches that we have seen today, and therefore humans, but also for machines. You get a lot of useful information. So let's go to see how metadata looks like. This is me. This is my metadata. So human readable, human friendly, a web page. But it has metadata behind the scenes. We can use, for instance, given that it is a web page, we can use schema.org to describe what this page is about. So my family name, my given name, my affiliations, what I know about, what is my identifier. Here I am using ORCID. I am the main entity of this page, and I am alumni or alumni for American people, well, US people, of these universities. Okay. And, well, this table is still kind of human readable. How does it look behind the scenes? So we have it on the corner, and we are using for this example schema.org. We have it in a format that it is called JSON-LD. JSON-LD is one of the formats that can be used in RDF, and RDF was produced by W3C. So RDF, I'm going to say this, my personal opinion, is how we used to call knowledge graphs back on time. Yeah, because RDF graphs, well, they are also knowledge graphs. So, but then Google came and it said and they said oh, now we have knowledge graphs, so more clever. But we have graphs and we have them for a while. So this is how it looks. So let's go into have a look to schema.org. I have to stop here. So why schema.org? Control vocabularies. Did any of the previous speakers mention control vocabularies already? I don't remember. Okay. Control vocabulary will help us to narrow down the possibilities. When you fill in a form that asks you country, that is already a control vocabulary because it's limiting the possibilities. Now you can have control vocabularies that will have kind of more characteristics, and some of those characteristics will give this control vocabulary some properties that will help machines to do some reasoning on top of it. It all comes from philosophy and mathematics. Because they follow kind of these mathematical logic rules, and this is big principles of semantic data, semantic web, and so on. This one in particular, schema.org, was created by the major search engines. Don't ask me which year, I forgot, but kind of 20 years now, I think so. At least, yes. And it was created because they wanted to serve people better. They wanted to make it easier for people to find things, but they also wanted to make it easier for them to kind of classify and categorize things. And thanks to schema.org is that you have the nice movie summary when you go to a search engine and you find the title, the actors, the year, related movies, the director, etc., etc. Because pages about that movie are using schema.org behind the scenes. So schema.org is very useful when you want to describe something that it is on the web, that it is in a web page. So how does it look, this control vocabulary? So it looks like a tree or a taxonomy. If you remember your school days about the taxonomy of life, where the humans are, the vertebrates, yeah? You remember that tree? That is a taxonomy, and it is organized in a hierarchical way. This is how schema.org is organized, and we have creative word that it is very useful for research, because we can describe articles, we can describe data sets, they will be here somewhere. We can describe software. Software, we will get there. Software applications, software source code. We can describe publication issue, volume for journals. There were some learning resources for training materials, for instance. We cannot yet describe machine learning models, working on it. So this is how schema.org use, and you will hear more about schema.org later in this talk. Let's continue. But then I have to move here. And I have to hide that thing again. So metadata comes in different ways. It can come, we presented before in JSON-LD, but it can be also an XML. Then it is not semantic. JSON-LD is one of the formats of RDF, so it is semantic. XML is not. RDF/XML is a semantic format, so can be converted to JSON-LD. There is a conversion between the two of them. But metadata is something that everybody works with all the time. I'm using here example of PubMed because I work in life sciences. So PubMed is the preferred repository for life sciences. And you see behind the scenes, they have metadata, and you can actually retrieve this metadata programmatically. We also have metadata for software. When you work with a GitHub or GitLab repository, you are already giving metadata without knowing it, because you are saying which is the license, who is working in this, who has contributed. It will automatically calculate which computational languages you are using. It will not know whether it is English, French, or Chinese, but it will know whether it is Python or JavaScript, or a combination of the two of them. You can also use tags. In here, we have tags. You will have a license. You will have how to cite this repository. All of that is metadata. And the more you use it, the better for research. Now, it can also look like this. Here we have like a very basic GitHub page with metadata about research software. Here we have one. Oh yes, you can see the mouse. Here you have one about training materials. Here you have one about research project. This one again is about a research software. And this is how it looks, again, behind the scenes using schema.org in JSON-LD. But this doesn't come on its own. This bit, GitHub, GitLab, will give this to you automatically. This bit, no, this bit has to be created. But when you have this bit, you could create pages that, for instance, aggregate all your software production or all the software production of your lab. That could be automatized. And then you could facilitate for aggregators, for Google search, for Google datasets, for NFDI software, to know more about your software. so more researchers know about your software or your data or your training materials, etc., etc., etc. FAIR for research software. Why do we need FAIR for research software principles if we already have the FAIR guiding principles for parentheses data? They are supposed to work for all digital objects, but there are some characteristics in software that will not be present in data sets, which are kind of the digital object that people will think most when they say like data in general. As a file in a computer, everything is data. But there are some characteristics for research software that make it slightly different from data sets. And this is why a group in the Research Data Alliance decided to work on the FAIR principles for research software. This is what we came up with. I'm not going to read them all. You will have access to the slides. You can go with that. If you have not heard about them, you might even want to go to the paper and read about it and how it has been adopted, etc., etc. But there are some things here that I want to highlight. They are underlined. Everything that it is underlined is related to metadata. Metadata is all over in the FAIR guiding principles and of course as well in the FAIR for research software principles. So we need a lot of metadata to make FAIR a reality. To implement FAIR, we need metadata. And who is going to give us that metadata? So every time that you submit a paper, even if you have it in, I don't know, Markdown, Word, LaTeX, or any other format, you still have to go to the platform and say, like, the title is this one. It is already in the document, but you have to write it down. The authors are these ones. These ones are the ORCIDs. This is the abstract. Some journals will ask you for funding. It is all, oops, sorry. Hope the microphone is still working. All of it is already in your paper, in the content, in the text, but you have to say it so again. And nobody says like, oh, why they cannot do this for me? Because you are already used to it. It's already normal. But when they tell you, okay, give me the version of your software. Where did you release it? Where you did this? The computational language. Oh, what they're asking me for more work is not normal yet. So we are working in this cycle and we want to get to make it normal. So at the beginning, it says make it rewarding, but I'm going to say that make it rewarding and make it required kind of happen hand in hand. Why do you provide release in Zenodo for your software? Oh, because the journal asked me for it. Oh, because my PI told me. Well, because I actually want people to know about my software. So we are working in that situation. We need infrastructure to make it possible. So then I don't ask you, what is the computational language that you used? GitHub already knows. Why am I supposed to ask you again and again data that it is already available? So we need to make it possible. We need to make it easy with training, with tools, until it becomes normal. So it is everybody's responsibility. And there are things that you can already do that will be useful for this. If you use GitHub or if you use GitLab, you can also create releases of your software. What is a release? In GitHub, GitLab, you make commits all the time. So if you say something like, oh, you might want to try my software, and this person goes and tries your software today, and again in 2 months, how many commits did you do in the last 2 months? So the software in 2 months is not the same one as today. So you create a release when you said like, my software now is mature enough to X, Y, Z. You create a release, it is a frozen version. So you can say someone else like, oh, you want to use my software? The latest available release is this one, and it is in Zenodo. Go and take it. You will get the information from it. So you work with releases, you work with versions. If you want to keep also kind of the live version, you can also work with the Software Heritage Foundation. CFF will make it easier for others to cite your software. And citing your software really should be as important as citing your paper, as citing your data. You invest a lot of work, right? I know that writing papers takes a lot of effort, but come on, doing software as well. And I'm pretty sure that anytime that you have to do some research software for your research, and if you are here, it's because machine learning somehow is of interest for you, I imagine. Machine learning without software is kind of difficult. So please use these kind of tools. They really have a look to, okay, I don't know how, oh, I can go back here. Have a look to this slide and see what bits you can do in your research software, please. It will make it better for other researchers that might be interested in reusing your software, in understanding what your software is doing, or your machine learning model when the model is already built. It's very important as well. So the CFF citation will also have tools that will create a first kind of template for you. So it will not take that long. It's kind of 1 minute that it will take, and it will already make your software citable and will provide more metadata that can be used. Okay. Metadata for software, we work with schema.org, but we also work with some other initiatives, bioschemas, schemas.science, code meta, the machine-actionable software management plans, and we have worked on these in collaboration, not only with NFDI for data science, but NFDI in general, Elixir Europe, which is for life sciences, and the Research Data Alliance. The metadata for research software, so I told you that still you have to provide a lot of things, but there are tools like this one, like SOMEF. Unfortunately, today the web version page is down, so we cannot go for the easy way. But what does SOMEF do? So SOMEF is a research software. They have nice documentation. They have the read the docs and everything. They provide information, how to use it, the Docker version, how to use it with pip, how to use it on our website that today is down, but it should be up tomorrow as well. And they will already extract some metadata. They extract the metadata using the software ontology, or they extract the metadata according to the code meta vocabulary. The code meta is also an extension on schema.org. Now, machine-actionable software management plans. Yay, finally. So, data management plans, I hope you have heard about them. Data management plans are commonly text-based documents, and in 2019, a group in the Research Data Alliance started working on a matching actionable layer, basically a semantically structured approach to model data management plans. The software management plans also, as a text-based document, questions and answers, kind of start sounding and being around in 2021, software management plans for research software, and we start working on matching actionable software management plans in 2022. This is how the data management plan, the matching actionable data management plan created by the Research Data Alliance looks like. So they are trying to model all the different bits. So remember the knowledge graphs that Jeanette showed you? So yeah, it's a graph. And they use the Dixo ontology for this. We want to do it with schema.org because then in this way we will make it easier for people to connect with other research artifacts. And we start working on the software management plans and the machine actionability. So there have been different software management plans that have been provided. One by Elixir, this one by the, oh no, this one is by Elixir. This one is, both of them are by Elixir, just one in text, the other one in question answering, like decision tree. There is another one by the eScience Center in the Netherlands, and there is one also by the Max Planck digital libraries. So this is the extension that we propose for the machine actionable data management plan. So let's go into add all the different elements that are related to software. And at the very, very beginning, we focused on the software source code, the one that you have in GitHub or GitLab, but also the software releases. And we use schema.org software application to model a release. So this is how the metadata looks. We are saying what comes from schema.org. We also provide some new elements. We use something for bioschemas, and we use something from the Machine-actionable data management plans. And this is how it looks. Quickly, I will show you. These are the types. A type is kind of a concept, like person. Person is a concept. So the concepts that we have are output management plans in general, and we did this mapping to data site, but we also have the software management plans. You are not seeing here the software source code because that one already existed in schema.org, and the software application already existed in schema.org. You are seeing here the new things that we are proposing. For the ones that already exist, what we propose is kind of some guidelines. If you go to schema.org, schema.org will have like 100, 150 properties that you can use to describe your software. We are telling you these are the minimum, really go with these. Whenever possible, we recommend you to really have these. And then some other that are optional, that are important for research software. If you can provide it, also do it. So the types are the ones that are telling you these are all the possibilities. What we call profiles are the recommendations on how to use it, so you don't have to fill in 150 options. Okay. Back here. Go back here. So we have the types, and we also have the profiles. So I show you both already. And what are we going to do now? What are we going to do next with this? We want to create this connection with the machine-actionable data management plans. We want to work together with NFDI consortia to create this core matching actionability layer for data management plans and connect them with the software management plans. So we can have like a global about matching learning management plans that we are calling in general MAPLAN, matching actionable plans. But we are also working, I told you, schema.org doesn't have any metadata about matching learnings. We are also working on metadata for matching learnings on top of schema.org. And we are doing this in collaboration with NFDI, Elixir, and RDA. And with this, I have finished. Thank you very much.